An Introduction to Cosmetic Buffering by Bianca and Maggie.
The purpose of this lab is to test a cosmetic company's claim that a balancing tonic will restore skin's natural pH.
We will be testing this by titrating the balancing tonic with a strong acid and a strong base. Materials include 0.1 molar NaOH and 0.1 molar HCl, pH probe, and a Lab Quest 2. A 250 milliliter flask and a 100 milliliter graduated cylinder. 50 milliliter burette and ring stand with clamp. NaOH and HCl are dangerous chemicals, so goggles must be worn in case they get into the eyes. And finally, the cosmetic product that we will be testing is Origin's Balancing Tonic. First, we filled the graduated cylinder with 0.1 molar HCl. Then the HCl was added to the burette to be titrated with the Origins. The burette was then clamped onto the ring stand. In the 250 milliliter flask, we added 50 milliliters of the Origins Balancing Tonic. pH probes are prone to being wrong, so we made sure to calibrate it to get the best and accurate results. We took the initial pH of the Origins tonic. For the HCl trial, it was 5.83, which is a little bit higher than skin's natural pH. We then began titrating it with the HCl drop by drop. We repeated this process, swirling it each time while recording the pHs. After about 0.5 milliliter drops worth of HCl was added to the mixture, the pH then plummeted, and so we stopped recording. The second half of our trial was very similar. We took 0.1 molar NaOH and poured it into a graduated cylinder before measuring it into our burette. The burette was then clamped into the ring stand. We measured out 50 milliliters into the 250 milliliter flask of our Origins Balancing Tonic. We calibrated the pH probe and then took the initial pH of the tonic, which we found to be 5.51. We then started titrating it with the NaOH drop by drop. We made sure to swirl the mixture all the while taking the pH with the pH probe. We stopped recording after 0.3 milliliters of NaOH was added because the pH spiked. This concludes the demonstration part of our presentation video.
A buffer is a solution that can withstand a small change in pH when a strong acid or base is added. It does this by being composed of a weak acid and its conjugate base, so that if an acid is added, the conjugate base will neutralize the H, and if a base is added, the acid will be able to neutralize that. We hypothesized that the tonic would contain a buffer because we assumed that that would be a very good mechanism for maintaining a pH. However, with just a small drop, the pH changed, indicating that the buffer capacity either was very, very limited or did not exist. Now, perhaps this would have been different with the acid naturally found on the skin, but in definition, a buffer should be able to withstand changes of strong acids and bases, and so we can conclude that our hypothesis was incorrect and there must be some other mechanism maintaining the pH. When we first tested the pH of the tonic, we found it to be around 5.5 to 5.8. This would make sense since the natural pH of skin is about 5.5, slightly acidic due to the thin protective layer on the surface referred to as the acid mantle, and when that combines with lactic and amino acids from sweat that naturally occur on the skin, the pH is that. Having a product that can maintain pH becomes incredibly important when you look at the results that can happen if your pH becomes too acidic or basic. Alkaline pH may lead to dry and sensitive skin, eczema, or inflammation, while an overabundance of acid could cause angry breakouts. We would hope this product would work, but it would not be by a buffer based on our results. Looking at the ingredients listed on the back of the bottle, the only acid that is obvious is coconut acid, but there is no listed conjugate base that would help in a buffer for this solution. With that being said, it might become a little concerning if a product meant for the face had a strong enough buffer to neutralize HCl and NaOH, both very strong acids and both highly unlikely to appear on the face. For this reason, we do not recommend this product if pH is the main concern.
A quick side note, we both realized that NaOH is in fact a strong base and not a strong acid. Thank you for watching. This has been a Bianca and Maggie production.